Welcome back to another episode of Algebra and Words, the video series on YouTube. In this video, we're going to sort of wrap up our discussion on the exponent rules, in which we're going to look at a problem with all the mixed rules. Okay? And if you want to follow along and read through an example in written form, you could do that in my book, Algebra and Words 2. And that's titled in the book, Different Ways to Simplify a Rational Expression. And if you want to see how to do that, that starts on page 46 of the book, Algebra and Words 2, which you can find on Amazon, and the link to that is in the description box below. And just to point out, in that book, I step by step go through 3 different ways that you can simplify that, because there are 3 different ways to start it and a few different ways that you can do it depending on which way you start it. But anyway, I'm going to explain that a little bit right now. So let's look at the problem that I have on the board. And the problem is the quantity or the group 14x to the negative 3 times y to the negative 3 over 7x to the negative 4 times y to the negative 3. And that whole group is raised to the power of negative 2. Now, before we get started, I want to just give an overview of 3 ways that you can start this problem. And as long as you apply the exponent rules properly, there's a number of ways that you can do it correctly. But I want to give an overview of the 3 ways to start it, because depending upon how you start it will depend on how the problem looks in the intermediate steps. But ultimately, you'll get the right answer no matter which way you start it, assuming that you apply the rules properly. So one way is, and I went over each of these individual rules, the product rule, the quotient rule, taking a power to a power, and what to do when you have a negative in the exponent, as well as distributing an exponent. I went over them in the previous videos, associated under episode 109. You can find the episode list in the description box below for each of those subtopics. But as I said, this is mixed. So what's one way that you can start this? Well, one way is, since this is a negative exponent here, you can flip the entire fraction. It's a rational exponent, same thing. You can flip the entire thing and automatically make the negative 2 a positive 2. That's one way to do it. That's completely up to you, but that's not the way that I recommend, and I'll explain why in a second. There's another way that you can start it as well. A second way is to take the exponent, whatever it is, it's negative 2 here, and distribute it to every term and every factor inside. The negative 2 to the 14, to the negative 3, the negative 3, etc., including to the factors in the denominator. Don't forget about those. You could do that as well. I also don't recommend that. I'm going to tell you the way that I recommend that you start it, especially if you're a beginner, and this is why. The third way that you can start this problem is by simplifying whatever you can inside the parentheses first. Now, technically, if you want to go by order of operations, you should say that you should simplify inside parentheses or groups first. There's a little flexibility with that here, because you can successfully flip first and change the sign, or distribute the power of negative 2 to every factor inside. But the reason why I recommend going with the third way that I recommended is because if you flip first or distribute first, you could end up with negative exponents inside at the end, or near the end, and in that case you would have to still account for the negatives in the exponents by moving them to the opposite part of the fraction. That's not a big deal, because you could do that in a few simple steps. But the reason why I recommend simplifying inside first is because basically, if you were to flip the whole fraction just to get rid of this negative and turn it into a positive, you're still going to probably have negative exponents at the end anyway. So I'd rather just simplify inside, then apply by distributing the exponent throughout, and then if there's any negative exponents in the end, then we'll just move them in the end. So anyway, let's get started. Focusing on simplifying inside first, let's start with the coefficients, 14 over 7. Now, since the 14 over 7 are both inside the same group of parentheses, we can easily simplify that. 14 over 7 is 2. So let's write 2 as the coefficient. Now, let's look for any other common bases. And you'll notice we have common base x over common base x. It's negative 3 in the top and negative 4 in the bottom. So I'm going to just show the intermediate step. We're going to apply the quotient rule by doing the top exponent minus the bottom exponent. So if we show all those steps, it's going to be negative 3 minus negative 4. And make sure that you show the minus and keep the negative with the 4 as it came. We'll simplify that in the next step. But let's look at the next variables, which are the common base of y. And I'm going to write common base y. And again, we're going to have negative 3 in the top minus negative 3 in the bottom. And you might know what that simplifies to already, but I'm just going to write negative 3 minus negative 3, just so we can see every step. Okay, put this in parentheses because we didn't account for that yet, and leave the negative 2 outside. Okay, so I'm just going to start to simplify below now. So now we're going to rewrite the coefficient 2, and now where we have negative 3 minus negative 4, which is plus 4, negative 3 plus 4 is going to become x to the 1, and normally you don't have to write the 1. I wrote it for now, but we could remove it in the next step. And just so you can see it, move it here. And now let's do the y. Negative 3 minus negative 3, which means negative 3 plus 3. Negative 3 plus 3 is 0. And again, you might know what that simplifies to, but for now I'm going to write it as y to the 0. Close that parentheses, and now don't forget the outer exponent negative 2. And now I'm just going to continue to simplify a little bit inside before we apply the negative exponent inside. So again, we have rewriting the coefficient 2, and since we have x to the 1, let's just make that x. And since we have base y raised to the 0, anything with the exception of base 0, anything raised to the 0 becomes 1. So since it's 1, I'm not going to write the 1 because 1 times anything is itself. So 2x times 1 is 2x. So this basically goes away as 1. Close that, and again, we still have the negative 2 outside, which we're going to apply next. And we're going to distribute this exponent to each factor inside. So I'm just going to show that it's going to be base of coefficient 2 raised to the negative 2, and x, which has an unwritten power of 1 to the negative 2, times negative 2, which is going to be negative 2. And now, in the last step, as I told you in the beginning, now we'll account for the negatives in the exponents by moving them to the opposite part of the fraction. So they're already over an unwritten 1, or in the numerator. So we're going to move both of these to the denominator, which is going to make 1 over 2 squared, and x squared in the bottom as well. If you want to expand or fully multiply the 2 squared, that's fine. You can make it then 1 over 4 x squared. So the answer is 1 over 4 x squared. Okay, so to summarize what we did, I just want to give a quick overview of the steps that we did. We have a rational expression, meaning basically a fraction with variables. The whole thing's in parentheses raised to a negative exponent. So what did we do? We simplified inside first. We reduced the coefficients 14 over 7 and made that 2. Then we applied the quotient rule for the common bases of x by doing the top exponent minus the bottom exponent, which ultimately became, ultimately became 1. And then we also applied the quotient rule of the common base y, negative 3 minus negative 3, which became 0, and y to the 0 became 1, and we just didn't write the 1 because 1 times anything is itself the 2x. Finally, after we simplified everything inside and applied the quotient rule, then we still had the negative 2 on the outside of the group, and we distributed that to each factor, and then we got rid of the negative exponent by moving each factor to the bottom and kept its exponent, but then as positive. And that's how we got to the answer. So that's a pretty good crash course on the mixing of exponent rules. We didn't really get a chance to do the product rule in this, but we got to do the 3 other rules. So anyway, I hope you found this helpful, and I hope you'll be able to do a question like this on a test on your own. So just remember to, in my opinion, follow the steps that I did in that order. I think it just overall makes it a little easier. I'll conclude the video in a second, but if you notice, look how this shrunk down to this by the end. So then we only had to distribute the -2 to 2 factors, and I think that ended pretty easy. Anyway, thanks for watching, and I hope you found that helpful and informative. If you did, please give a thumbs up. Please subscribe to the channel so you can be alerted when new videos come out. Check out the links below to the episode list, as well as other platforms that have videos, as well as to my books on Amazon. Also, make sure that you check out the videos on Facebook and Instagram, because they're just supplemental videos to these topics. Anyway, thanks for watching. And in the next video, we're also going to cover scientific notation, which involves exponents and kind of is an exponent rule, but it's kind of its own thing. So I'm going to dedicate a video just to that. Anyway, thanks for watching. See you in the next video.